Hello guys and welcome back. Today we will again continue our real JEE Advanced question series. As you might have seen the thumbnail, we are taking a question on functions after a long time because I think functions has been really ignored all this time and it's a really important chapter, right? Not only important, like many difficult questions have been made from this in the past. So I guess you can see on the screen, I guess, this will be our first question. But before that, just a few words. Before beginning, just a credit to the actual owners of these questions. I have not created these questions. They have been created by the Maths Explorers group. I have attached their Telegram link in the description. In case you want to view the questions they have created, you can go there and view them. Like, these questions are really good. So hats off to them. Really commendable work they are doing. And guys, just a little bit more I want to say is that I was getting a few comments that I should, like, people were messaging me on Telegram that I should bring in the JEE Mains question series as well. So if you guys want me to like continue this series parallelly and bring in a JEE Main question series as well, then please write to me, okay? Because actually these questions take a lot of time to solve. So if that is what is needed, then I have to do something. Anyways, whatever, like, what I want to say is whatever recommendations you have, drop them down in the comments, okay? Okay, enough of talk. So this will be our first question, guys. Like, this is a really good question, okay? You can give this a star mark. Really standard and good question on function and functional equations also, as you can see. So you can try it out. Do try to solve all the options because this will go a little lengthy, but I hope if you have learned your functions properly, if you have done sums, you might be able to do this, okay? All on manipulation. So try it out, guys. I will wait for a few seconds. You can pause the video and then I will start solving. Okay guys, I guess now it's time for us to solve this. So basically I don't have any space here, but before proceeding, we will just take an overview. So basically f is mapping from q to n, that is from rational numbers to natural numbers. F of 1 is given as 3 by 2. We have this huge functional equation, and after that these are some things that we have to evaluate. So basically, as much as I can understand, we have to find out f of n, okay, as much as I can understand. So finding out f of n from this, like guys, one thing, if you have gone for anything of that sort, that we have to partial differentiate this equation, make a differential equation and all, then do not do that because you will land in absolute rubbish that will not take you to anything productive, okay? Like, if you actually observe this functional equation, this bracket, if you like add these two, right, you will get x plus y plus 1 on both the numerators, as well as if you take xy common from here, you will also get x plus y plus 1. That should only give you a hint that there is something repeating, okay? And when we can actually have such observations, there is a pretty clear hint that maybe this can be solved without calculus also, okay? So the answer is yes, we can solve this without calculus, and I will start solving it. I will change the page. I hope you have written this down. So guys, proceeding, first I will write the question once. This is our f of x plus y, which was given to be equal to 1 plus y by x plus 1 times f of x plus of 1 plus x by y plus 1 times f of y, and finally in another bracket we will have x square plus xy plus xy square, okay? So what I am doing is I am taking f of x plus y. We are writing this originally. I am first adding up these fractions. So we will get x plus y plus 1 whole divided by your x plus 1 f of x plus of x plus y plus 1 whole divided by your y plus 1 times f of y plus of your x square y plus xy plus xy squared. And actually you can also write this term as your xy times x plus y plus 1. Now I can observe there is an x plus y plus 1 everywhere, so why not like eliminate that from this RHS, okay? So what I'm doing is basically I'm taking x plus y plus 1 common from all sides and taking it to the left hand side denominator, or maybe this was too complex. Simple ways if I can explain it, I would just divide this entire expression with x plus y plus 1, okay? So finally we would have f of x plus y whole divided by x plus y plus 1 to be equal to f of x whole divided by your x plus 1 plus of f of y whole divided by your y plus 1 plus of x y. This is our final equation. And now guys, if you actually notice this functional equation very carefully, you will understand that there is something hidden here, which is basically that we can actually replace this entire thing with a like dummy function, okay, for some time. So if we actually take some g of n, say, okay, g of n to be your f of x by x plus 1, then actually this thing will become like, say, g of n is equivalent to g of x okay guys, just a minute. I guess I should write this with something else. I will change the page. Actually the notation was wrong. I am changing the page and writing. Don't write that actually as f of x, because that will be like f of x is present, okay, it will be discrepant. Write g of n to be equal to some random g of x by x plus 1. This looks better. So now actually we can replace this equation with g of x plus y to be equal to your g of x plus of g of y, and xy stays as it is, okay. So basically this is the equation which was hiding in that huge thing. So now we actually, our target is to find out an expression for f of x or f of n, whatever, okay. Rather f of n, because everything is given as f of 20. If you observe in the options, f of 20, f of I guess 10 was also there. So everything is given in terms of n. So our target is to find it out in terms of a number n, so that we can put it and compute the result, okay. So what I am doing is, first let's try to find out, say I am putting x as equal to n and y as equal to 1, okay, and rearranging this or rewriting this. Basically we will have g of n plus 1 to be equal to g of n plus of g of 1, and this will be n into 1 n. So if we bring this thing to our left hand side, so this will be g of n plus 1 minus of g of n to be equal to g of 1 plus n, okay. So after this I actually can see something here, okay. So what I can see actually is this thing g of n plus 1 minus g of n, we have to, like, what I am going to do is right now, if you actually remember our telescoping series, okay, our telescoping series, like that different series in which we have things like this, say g of 2, I'm writing the original expression only, what we will actually get, g of 2 minus of g of 1 plus of g of 3 minus of g of 2, okay, and this goes up till your g of n minus of g of n minus 1. So if you actually observe here, what will happen is g of your g of 2 will get cancelled, g of 1 will remain intact, g of 3 will get cancelled, and at the last g of n minus 1 will remain cancelled. So g of n minus g of 1, okay. Basically what I am trying to say is this thing here is actually sigma of this thing. Or maybe just a minute, I will write this down clearly, okay, otherwise it will become messy. I'm changing the page. So guys, actually if you see, what I am doing is, this is nothing complex, okay. I am just taking the things reverse, like what we actually find telescoping series in the forward direction, I am taking that towards the reverse side, okay. That is actually the trick in this question, and that is why it becomes a bit difficult. So what I can actually write is g of n minus of g of 1, we derived this thing just a while back, okay, with that g of 2 minus g of 1 plus g of 3 minus g of 2. So if we actually want to write that with a sigma expression, you will get that as sigma k equals to 1 till n minus 1. Just notice my expression there, you will understand, okay, or I will show it. Yeah, just see this expression. If you see this and match this with this, try to write a general expression, you will get your g of k plus 1 minus of g of k. And that is actually the trick, because we have this thing here, okay. That is actually the trick. So this was a bit complex, guys. Like, we are actually bringing out a telescoping series of step reverse to get our result. Okay. So I guess now this thing can be written as sigma k equals to 1 till n minus 1, and now because this thing is equal to this thing, we can write this bracket as g of 1 plus k. Okay. So what we will do now is, let's sum this thing up. So this thing will be your, I guess, n minus 1 times g of 1, because g of 1 is a constant anyways, and this thing is your k times 1 to n minus 1 summation. Okay. Okay, so this thing is here actually n into n minus 1 by 2. So now I guess if we take g of n, we take it to, like, let it be on the left hand side, and g of 1 taken to the right hand side, this will become n times g of 1 plus n into n minus 1 by 2. This is actually the most valuable expression till now in this entire question, okay, because this will give us everything we want. So for that, actually we need g of 1 because that's still not found. So I will change the page and further manipulate. So we knew that our g of n, this thing is actually equal to any g of x by x plus 1, okay. Or guys, actually I should have maybe written this as f of x only. Yeah, actually I will just change the notation. Just a minute, guys. Here, so here in this part, just write this as f of x, okay. I actually had written correct. Maybe some sort of bluff in my mind. Anyways, so f of x by x plus 1, and actually the thing is we are replacing f function by g function, right? So g should be expressed as a function of f. That was my mistake. Please correct it, guys, okay? It will not be g of x because it was not predefined. And actually this definition is also very important because right now we need our g of 1, and to find g of 1 we will use this expression. Why? Because we know f of 1. Okay, so I am going back to the page. So here this will be our f of x. So this was known. So basically if we try to find g of 1, this will be f of 1 whole divided by a 1 plus 1. So f of 1 was 3 by 2, this thing will be 3 by 4. Okay, and also if you are making this thing n, please also make this n. These two quantities will be absolutely equal. Here also you will have n, or I am writing it clearly. G of n will be equal to f of n whole divided by n plus 1. If you want x, you can write g of x equal to f of x by x plus 1, whatever you wish. Okay, so I guess now we have found out our g of 1. So let's plug it into our equation, which will be g of n is equal to 3 by 4 times n plus of n into n minus 1 by 2. Okay, and guys, please, this thing is like, if you are writing g of x, write f of x by x plus 1. If you are writing g of n, write f of n by n plus 1. Okay, there is like, I did a mess in between x and n, but actually I'm trying to derive everything in terms of n because n is the normal symbol for a natural number. Okay, and it is also mentioned in the question. So I hope it was clear. So now let's manipulate this thing. Little bit of manipulation we will have. This will be 3n by 4, and we can write this as your 2n into n minus 1 whole divided by 4. So if we add it up, I guess we will have your 3n plus 2n squared minus 2n whole divided by 4. So this thing, I guess this thing will actually become n into 2n plus 1 whole divided by 4. This is your expression for g of any n. Okay, this is the expression for g of n. And now from here, our f of n, this will be n plus 1 times g of n. So finally we have a standard expression for f of n, which is n into 2n plus 1 into n plus 1 whole divided by 4. And now actually, like, dealing with all these is not looking very good. We want a better representation. So if you actually notice, except this 4, every other term is present in our summation for any square of any n natural numbers. Okay, So it is n into 2n plus 1 into n plus 1 whole divided by 6, by the way. So we can actually convert that and write our f of n as equal to 3 by 2. A factor of 3 by 2, because there would be 6 here and 3 by 2 would adjust it as 4. And this would be sigma k equals to 1 times n k squared. This is a better looking expression and also the final expression for our f of n. Okay. Like this was the key to our question. Like key to solving the options. So we have that key and now we can proceed towards the options and check whatever is there. Okay. So let's evaluate the options one by one. So guys, I guess in our option number A, we actually had to calculate f of 20. So let's do the calculation. This will be our 20 by 4. And there we had n plus 1, so 20 plus 1. And I guess 2n plus 1, so 40 plus 1. So this thing will be 20 by 4 into 30 into 50. Or just a minute guys. Okay, not 50. This will be your 41 and this will be 21. Yeah. So 5 into 21 into 41. This thing is 5 to the 10, 1 the 5 and multiplied by 41. I will just calculate this. I guess we are having 4305 as the final answer. So 4305 is the value of f of 20 and it was obviously given in the options. So our option number A becomes correct. Okay. Now let's proceed to our option number B. In option number B, I will just read it out for you guys once. So our option number B read that if fn is equal to 1, there lies only one root between 0 and 1. So a little bit of calculus also involved here. So for that we have to check the sign change. So let's go and check it. So first we put fn is equal to 1. So that will give us our n into n plus 1 times 2n plus 1 is equal to 4. Okay. And now say we take this thing, from here we take a function h of n, which is equal to n into n plus 1 into 2n plus 1 minus of 4. Okay, this is n. So if we actually take the border points only, our border points were 0 and 1. Let's take the border boundary points. Okay. But before that, we will also try to ascertain whether this function is increasing or decreasing. So I guess like it will be very natural, obviously. You don't need to actually calculate, but still I will calculate it for you. This is our n square plus n times of 2n plus 1 minus 4. So this will be 2n cubed and I guess plus n square plus 2n square, so plus 3n square, and this is a plus n minus 4. So if we actually calculate h dash n, the first derivative, it will be 6n square plus of 6n plus 1, and perfectly this is always greater than 0, so h of n is increasing. It is an increasing function in the interval 0 to 1, and obviously it is for n greater than 0, which is very satisfied by our interval. Okay, so I guess now we are in a good position. H of n is already found to be an increasing function. So what we shall do is, like, let's find the value of the function h of n at the boundary points. If we put h of 0 and calculate it, it will obviously be minus 4. And if we calculate h of 1, this thing is 1 into 1 plus 1 2 into 2 plus 1 3 minus 4 6 minus 4 2. So if you actually observe our 0 and 1, the output of 0 is actually a negative point and the output of 1 is a positive point. And this function is increasing, so there is no other path. It has to go like this. So yeah, there will be exactly one root. Okay. Exactly one root. And if you ask why, that is because the function is increasing, first thing, and second thing is the function, like, it is strictly increasing. I should also write strictly. Okay, it is strictly increasing. It cannot be like it will go like a wave, once increase then decrease. Nothing like that can happen. It will only increase. So if this is negative h of 0 and h of 1 is positive, it has to cross the x-axis, it will increase, and it will cross the x-axis only once. So I guess our option B is also correct. So that's it for option B, guys. Now let's go on to our option number C. So guys, in option number C, there was an expression given. So I am directly like writing that out. The left hand side for the expression, actually if you take 3 square common from that, you will get a 1 square plus 2 square plus of 3 square up till n square. So this is nothing but your 3 square times the sum of the squares of, n natural numbers. So this will be n into, I'm writing n into n plus 1 times 2n plus 1 whole divided by 6. So we have a factor of 9 by 6 here. Okay. And basically our f of n, as far as I remember, had 3 by 2. So 9 by 6, and our f of n had a factor of 3 by 2 here. So I guess that's multiplied, 3 by 2 multiplied by 6. So this becomes 6 times f of n. Because all the other brackets terms, all this part was exactly same. Okay. So yes, our option number C is very, very correct. So moving on to our final option number D, guys. I guess we had to find out this equation, like we had to solve this. To f of n was given to be equal to 2023 times n plus 1 c2, and we had to solve for the value of n. I guess that was it. So let's solve it, guys. So what I shall do is, now I will just plain simple put our 2f of n. So 2f of n, this thing is given to be your n into n plus 1 times 2n plus 1, and I guess I will just check the value. It was 3 by 2, I guess. And obviously the 2, I guess it gets cancelled, so 3. Okay, this is it. Okay guys, it's not 3, I'm sorry. It is actually, it was n into n plus 1 into 2n plus 1 by 4, right? So multiplying that by 2, this will be by 2. Yeah, now it's correct. So this was our LHS. And for our RHS, let's calculate that roughly. This is 2023 times n plus 1 C2. So 2023, just break it into normal factorials. N plus 1 factorial, and this is whole divided by your, I guess, 2 factorial into n minus 1 factorial. Okay. So if we actually like split this up, this will be this factorial up. This is your n into n plus 1, or rather I should write n plus 1 into n minus 1 factorial. So this and this get cancelled. So this eventually comes out to be n into n plus 1 by 2. This is our RHS, and our LHS is n into n plus 1 into 2n plus 1 whole divided by 2. So 2 cancelled, n into n plus 1 cancelled. So 2n plus 1 is 2023. So 2n is 2022, and I guess n is 1011. That's our answer, which was obviously given. So option number D is also correct. So that's our done question, guys. So A, B, C, D, all the options are correct. So that's it for the first question, guys. This was a legendary question. Okay, like really good question on functional equations. You need in depth, like this will, if you go randomly solving it with anything that you have got, then you won't be able to solve it. You have to go step by step as I went. Okay, like huge practice for functional equations is needed. Anyways, guys, we will proceed to the next question for today. So here is the second question, guys, and this question is also a really good question. I liked it. Okay, I will also tell you, like, there are actually a lot of methods to solve this, some in higher calculus, but there is a formula also which you can actually remember. Like, I will give you a little bit of blooper before solving. Actually, g of x here in this question, it will come out to be a linear equation. Okay, a straight line. G of x will be x minus something. I'm not telling that. G of x will be a straight line. F of x will be a curve. So minimum distance finding is actually simpler. But if there is a case where g of x and f of x, both of them actually come out to be arbitrary curves, then also you can find. There are ways, but that actually becomes a bit tedious. Okay, so I have a formula. It is very easy to remember. It's, I don't know whether, like, I had learned it during my preparation. I don't know whether it is included in the JEE syllabus or not, but it was there in IMO. Okay, it is there in IMO. Anyways, I will tell you, it is also not very difficult to remember. If you want, you can remember that just for emergency situations. Okay, it is a very simple formula. Anyways, guys, this question is not very difficult, like what I said right now. But yeah, it is a good question, so please give it a try with patience. I will wait for a few seconds and then start solving. Okay guys, I guess now it's time for us to start solving this. So basically, actually, like, although I gave you a blooper before that this will be a straight line, before that we don't like I gave you the blooper so you knew. We don't know what kind of functions these two are, and there is actually interrelation given. Okay, so for that we need to actually first find out f of x and g of x defined in a defined way, and only after that we can go on to solving this. So what I will do is, first I will write down our equations given. First is the f of x, which is given out to be equal to your x cube by 2 plus 1 minus x times of integral 0 to x g of t dt. And our g of x, this is given to be equal to your x minus of integral 0 to 1, I'm sorry, f of t dt. So what is actually playing in my mind is, this thing is a constant. Integral 0 to 1 of any function, it will be a constant. So let's take for some time k as a constant to be equal to integral 0 to 1 ft dt. Okay. And now I'm changing the page guys because I don't have space here. So now after doing this substitution, g of x for the time being, it becomes x minus k. Okay. So now we actually need to put this in f of x and find out. So what I will do is, let's manipulate f of x with this expression. So f of x, this actually comes out to be equal to x cube by 2 plus 1 minus of x times, it was integral 0 to, I guess, x. Yeah, it is integral 0 to x g of t. So g of t will be t minus of k, and this is your dt. So let's manipulate this thing first, okay, and then we will actually get something fruitful. So if we write this, this is your x cube by 2 plus 1 minus of x, and doing this integration is, I guess, very easy. This is t square by 2 minus of k of t, k into t, I'm sorry, and this is from 0 to x. So if you actually manipulate this x cube by 2 plus 1 minus of x, this thing actually putting x square by 2, you will have one x square by 2 term. One term will be kx, and when you put 0, both become 0. Okay, not both actually, just a minute guys, I will check. Okay, both actually become 0, sorry. So this thing is within the bracket. And now if we multiply x to this, minus x cube by 2 minus and plus x cube by 2, both are cancelled. So you will directly have minus minus plus 1 plus kx squared. Okay. So our f of x, it comes out to be, I guess, 1 plus of kx square. And now we will put again, this is our result we obtained right now. Okay. And we are now putting this again into this equation we substituted for before, and then we will get our k. So k is equal to integral 0 to 1 plus of kx squared dx, or rather it was in dt, so take dt only, kt square dt. So this thing actually becomes t plus kt cube. So 0 to 1, I guess it will be k equals to your 1 plus k by 3. So 2k by 3, bringing this to the left hand side, this comes out to be equal to 1. So k, this thing actually becomes equal to 3 by 2. So we finally have our value for k, and now our f of x and g of x are perfectly ready. So let's write them down. So guys, if we finally write down our f of x, this comes out to be your 1 plus, I guess, x cube by 2 plus 1 minus of that we had actually taken as, I guess, 3 by 2, and this is your x. Okay. And g of x, this comes out to be x minus of 3 by 2. Or maybe, okay guys, just a minute, I guess I did a mistake. Wait, f of x I wrote wrong. F of x was actually equal to 1 plus kx square, right? So this will be 1 plus 3 by 2 x square. Yeah, now it's correct. So this is our g of x and f of x. So what I will do is, actually, if we, okay, I will give a read on to the question once, so you will understand better. So basically here we have to find out the minimum distance in between the functions f of x and g of x. So minimum distance, okay. Now because we have a straight line, actually for that we have an advantage. What we can do is we can actually take any general point on the curve f of x. Then if that is a point, right? So perpendicular distance from of a point from a line, for that we know the formula from straight lines. And now using that, if we take that expression, minimize it, then we will actually get our desired result. Like whatever value of the variable we get after minimizing in that expression, we will put that into the expression and then we will get our minimum distance we need. So I guess we will go on to it. Let's do it, guys. So what I'm doing is, I am our g of x was, I'm writing g of x as y is equal to x minus 3 by 2. Okay. So let's take a general point on this and let this general point be, say, x comma 1 plus 3 by 2 x square. Okay, not on this actually. Sorry. This is on f of x. Okay. So d of x, let this be our distance expression which we have to minimize after a bit. This will be, I guess, if we rearrange this, this is your x minus y minus 3 by 2 equal to 0. So if we write it, I guess this will come out to be like the formula directly we are putting. So x minus of 1 plus 3 by 2 x square, and this is minus of 3 by 2 whole mod, whole divided by your root under. This will be 1 square plus minus 1 square, so root 2. So basically our d of x, that comes out to be 1 by root 2 times mod of minus 3 by 2 x square plus x minus 5 by 2. Okay. Now, although we have a mod, let's not do anything with the sign in this expression, because whatever value will come, we will modify that according. Okay. So let's take this quadratic. This is a quadratic, right? So let's take this to be h of x. Okay. H of x, which is equal to minus 3 by 2 x square plus of x minus 5 by 2. Now, if you actually observe carefully, this is a quadratic expression which has a shape like this. It is upside down because a is negative. Okay. And a, like, this will be some sort of. So if we have to actually minimize this expression, then only we can minimize d of x. We have to actually calculate the abscissa of the vertex. Right. I hope that is clear. So vertex, like, not, we don't need the entire vertex, we can only find the abscissa. At vertex, your x, which is the abscissa, will be equal to minus b by 2a. So I guess this thing comes out to be equal to 1 by 3. Am I correct? Yes, I guess I'm correct. This comes out to be equal to 1 by 3. And guys, if you actually have, like, if you feel confused in this also, what you can go is you can directly compute h dash x, which comes out to be equal to minus 3x plus 1, and put that equal to 0. That is also working. Okay. So x equals to 1 by 3. Either way you can do it. So I guess we have our values ready. So let's plug it into our final equation. Okay, let's find out h of 1 by 3, and then we will plug it into d of x. So h of 1 by 3, it actually comes out to be minus 3 by 2 times 1 by 3 squared plus of 1 by 3 minus of 5 by 2. So this thing is your, I guess, minus of 1 by 9, right? So 3 into 2 in the denominator, which means minus 1 by 6 plus 1 by 3 minus 5 by 2. So guys, I will quickly calculate this and tell you the value. Just a minute. Okay guys, so the value is coming out to be minus 7 by 3. Okay. So I'm not taking another page. We can write it here only. So if we actually go and find out our d of x right now, which is our minimum distance. our value we need. So that comes out to be equal to modulus of minus 7 by 3. So plus 7 by 3 by root 2. So 7 by 3 root 2. This is our answer. And I will match the option. I guess it is option number C. Okay, this is our answer. Now, as I promised, I would tell you a separate formula also. Like, see, we can actually find out the minimum distance, but if f of x and g of x were two arbitrary curves, okay, like you can understand your f of x has come out to be some sort of a parabola, and here g of x is a straight line, so you are a bit lucky. But if it comes out to be something else, then taking points and solving very possible, but that is actually pretty lengthy. Okay, so if you can, I am not forcing, if you can remember this formula. This is pretty famous in IMO mathematics. Okay, you can if you want. I am writing that formula. So our formula actually will be, you can write this like this. This is actually L square. Okay, L square means L cross L. Like our 2D plane, we in Euclidean geometry, or rather I should say Euclidean geometry, L cross L is actually our Euclidean plane, the 2D plane, or you can write it as L square. So there the distance, like not only distance, minimum distance between two arbitrary curves. If you want, you can remember. Okay, I'm not forcing you, because this thing, like, already you have too much pressure in your mind, so don't go to take any more if you are not willing to. So this thing actually comes out to be root under integral 0 to 1 f of x minus of g of x whole squared dx root under. Okay, some sort of, this is very similar to your something you have learnt in physics in alternating current. I can remember this is something like very similar to root mean square. Okay, very similar to root mean square. So this is it, and also this is for the distance over the interval 0 to 1. Okay, or maybe I will generalize that. Just take, like, if you have x initial to x final, the interval, then you will evaluate this from x initial to x final. That is better. This is a generalized expression. In our question we had 0 to 1, so I wrote 0 to 1. Okay, so this is it. If you can compute this, like, only calculation will be a little bit of cost of your time, but if you can calculate this, you don't have to mess up with all that. Okay, so this will be your extra formula if you want to remember. So that's it for today, guys. I hope you like these questions. I will bring in such questions in the next videos also. Any doubts, do ask out to me in the comment section, and please do like, share and subscribe, because it takes a lot of hard time to bring these questions in. So that's it for today, guys. End of this video. Thanks for watching.